Hi everyone, let's solve this problem. Integer break. Given an integer n, break it into sum of k positive integers. That means if I am given 2, I'll break it into 1 plus 1. The sum of the broken down integers is equal to n, where k is greater than or equal to 2. So I can break this particular n into multiple numbers. It should be at least 2 numbers or more. And those broken numbers should be positive integers. And maximize the product of those integers. Return the maximum product you can get. So let's try to understand that. Let's say for example I have n is equals to 2. I can only break it into 1 comma 1 because if I break it into 0 comma 2, 0 is not a positive number, so it's not applicable. So 1 plus 1 is 2, 1 into 1 is 1. So that's the reason we kind of get 1 here. And then let's take for example n is equals to 3. Here 1 comma 2 is possible. Alright, 1 comma 2 is possible, 2 comma 1 is possible, and 2 can be further divided into 1 comma 1. 1 cannot be further divided because that's the smallest unit or smallest positive number, and 1 comma 1. So in this case I have 1 comma 2, 1 comma 1 comma 1 and 2 comma 1. So, and one more thing you need to observe is that we are solving the same tree again and again, so we might need to use dp. That is one of the suggestions. Now let's understand n is equals to 4. In this case it will be 1 comma 3, 2 comma 2, 3 comma 1. Again at this particular point 1 into 3 will be product is 3, 2 into 2 product is 4, 3 into 1 product is 3, and I can even further divide it into like more numbers 1 and 2, right? And 2 can be further divided into 1 and 1. So there are couple of possibilities here, 1 1 1 2. So this particular 1 into 2 will be 2, 1 into 3 we got it as 3, and I can also consider 1 1 1 1. So in this case 1 1 1 and 1 will be 1. So there is a possibility that I will need the answer which is without breaking the number into further parts, or I can break it into the number into further parts. That's up to us. But if you see here again, this particular tree and whatever tree we will get with respect to this particular number 3 will be same. So we might need to use dynamic programming. So initially, let's say for example, if I am taking a particular number I, then I am doing num minus I, right? So if my number is, here the number is 3, right? I am dividing into I 1, then 3 minus 1 is 2. That's how I am getting 1 and 2. Similarly, in this case, if I is 1, then 2 minus I is 1. So that's how I am getting the values. So the answer will be always DFS of I into DFS of num minus I, right? This is what will give me the answer. But as I discussed, there is an answer possibility which says that I don't need to break it into further numbers. So for this there is a special case. Let's say number is equals to n, which is our given number, then it will be 0, because let's say 5, if I kind of don't want to break it further, it will be 5 0 or 0 5, right? That means the product of those numbers will be 0. So that is the reason it will be 0. Otherwise, if I don't want to break it further, the maximum product that number can give is the number itself, right? So if you see here, the number itself, right? So that's the reason we will use this particular condition. Otherwise, we will try to find a breakdown of those numbers further. So let's try to write the recursive code for this first, then we'll come to DP. We'll use a recursive function here with variable num, and we will return the answer which we get from this particular function, and we are going to call it with n. As we discussed, if number is equals to 1, we will just return 1 because there is no further breaking down of this particular number, right? And also, as we discussed, we will have a result which is if number is equals to or like the number given to us n, then the result, if we are like taking, we are not breaking that number further, that means the answer will be 0. But if there is any other number, then the answer will be number. So this is for not breaking the number further. Otherwise, we will break our number, will start breaking the number using starting with 1, because 1 is the least positive number possible. I less than n, I plus plus. And here why are we not going till equal to n? Because again, if I kind of take, if n is equals to 4, if I take 4, then the other number will be 0, right? 0 is not allowed. So that's the reason it will go till less than n. And now my value will be I into num minus I, right? And also this should be num, because we are recursively calling. So for this num will be 4, for this particular sub problem the num will be 3, for this sub problem the number which we are passing will be 2, and so far. So the number will be here, the condition will be num, and then we will update our answer result with maximum of result comma value. So here it's simple, if we are not breaking down there is some answer, and if we are breaking down further we have some answer. So we are kind of getting the maximum of not breaking and breaking sub problems here, and then we will be returning the result from here. So let's try to run this code. Right, it is successful. Obviously it will run into a time limit exceeded issue. Let me show it, because this is kind of n power n solution. So for every number you are kind of calculating n minus 1 solution, so it ran into time limit exceeded. So let's understand now the DP solution. DP solution is nothing but if you have already calculated the value, let's say for 3, I will store it. This is the number and this is the result which we got. If I, for a number 3, if I got 3 ones, for this I don't need to calculate, I'll reuse it from the DP array or DP storage. So that is how we are going to do. So initially DP dot set of 1 comma 1. So if the number is 1, the answer is 1, which we know, so I can get rid of this particular value. If dp dot has of number, that means it's already calculated, then I will just return from the stored TP value. And also we will have to store, whenever we calculate a particular result, we will have to store it. Now here what we have done is we have created a storage, and if we have already calculated an answer for that particular number, we are returning from the calculated answer itself, and whenever we are seeing a new number, we will calculate and we will store it in the DP. Now let's try to run it. Let's submit it. Now let's also understand the time and space complexity of this. So if you see here, you are iterating from n, initially n number which we are passing is equal to n. So this loop will be iterating over n times, and for a particular subtree it will go like these values can, like it needs to calculate all the values like 1 2 3 4 5, right? If n is equals to 5, it has to calculate in the first subtree, so it will be n. After that it will just keep taking the values from the cache or the DP value. And the space complexity here is big O of n, because we are kind of storing the like number and also its result in the DP. So that is the reason. I hope the solution is clear. Thank you.